Hi student, I'm back again. Today we are going to deal with P block element, that is group 15, 16 and 17. We are going to have a very good session with some very interesting questions. Okay, so let's begin with it. Yes student, have a look at this question. It says concentrated nitric acid, which is a very powerful oxidizing agent. Nitric acid upon long standing turns yellow brown due to the formation of. Now, if you see, pure nitric acid is colorless. Pure nitric acid is colorless, but if you allow the nitric acid to remain standing for a long time, it decomposes to give you water, oxygen and nitrogen dioxide gas. Nitrogen dioxide gas. Now because of this NO2 gas, it gives yellow brown coloration. Yellow brown coloration. So the answer for this question will be NO2, that is B. B is the correct answer for this question. Okay, let's go for the next question now. Among the following, the number of compounds that can react with phosphorus pentachloride to give you POCl3 is. Now let's see, the given options are oxygen, carbon dioxide, sulfur dioxide, water, sulfuric acid, phosphorus pentaoxide. So among the following, PCl5 will react with sulfur dioxide to give you POCl3 plus SOCl2. So it will react with sulfur dioxide. With respect to water, H2O, it will give you POCl3 along with HCl. Along with HCl. So it will react with water also. With respect to sulfuric acid, H2SO4, it will give you SO2Cl2 along with POCl3 along with HCl. Okay, now you just need to balance this equation. So 2 here. Okay, then 2 HCl, 2 hydrogen, but sulfur is 1, oxygen is 2, 3 oxygen, PCl5, SOCl2, should I put 2 here? Okay, and 2 here, 2 5s are 10 chlorine, 2 3s are 6, 7, 8 and 2. Now it's balanced. It's balanced. So with H2SO4 also it reacts. What about PCl5 treated with P4O10? Oh, it will give you POCl3. Okay, so I put 6 here, 6 phosphorus and 4, 10. Okay, along with it, so I have 5 6 are 15 chlorine. Okay, 15 along with oxygen, 4 phosphorus, 6 phosphorus here, 10 here, 6 and 4, 10 phosphorus, 10 oxygen and chlorine becomes 30, 6 5s are 30. So reaction is balanced. So in this case, it will react with C4H10 also. So your answer for this question is 4. It will never react with oxygen nor with carbon dioxide. So the answer for this question is Among the following number of compounds, it can react with 4 of them. Okay, so answer is D. Now let's go for the next question. Which of the following statement is true? First, H3PO3 is a stronger acid than H2SO3. Phosphorus acid, is it stronger than sulfurous? No, it is sulfurous which is stronger than H3PO3. So the first statement is a false statement. What about the second one? The second statement, it says in an aqueous medium HF is stronger acid than HCl. No, it is HCl which dissociate faster than HF. So this statement is also false. The third one, HClO4, that is perchloric acid, is a weaker acid. No, you know chlorine, it forms 4 acid. It is hypochlorous, chlorous, chloric and perchloric. So the strength of the acidic nature will be perchloric will be more stronger. So in that case, option C is also wrong. What about D? Nitric acid is a stronger acid than HNO3. Nitric acid. This is your nitric acid. Yes, nitric acid is more polar compared to nitrous acid. So your answer for this question, which is a true statement, is D. D is the correct option. Okay student, have a look at this question now. It says, which is the most thermodynamically stable allotropic form of phosphorus? Phosphorus has 4 allotropic forms: red phosphorus, white phosphorus, black phosphorus and yellow phosphorus. So among the following, the one which is thermodynamically very stable is the black phosphorus. Reason, black phosphorus ignition temperature is very high. Temperature is high, very high. Secondly, it is inert and it has a layered structure. It has a layered structure. So these 3 points makes it thermodynamically very stable. So your option for this question is C, which is the correct option. Student, have a look at this question now. It says, which blue liquid is obtained on reacting equimolar means same amount of 2 gases at -30 degree. So among these gases, which 2 gases will react to give any one of them at -30 degree? So we know that nitrogen dioxide gas in equimolar amount at a temperature of -30 degree will give you N2O3 liquid, which is blue in color. So the 2 gases which we are combining is NO2. They are one and the same only, but equimolar amount. So we are getting N2O3, which is a liquid. So your answer for this question is B. B is the correct option for this question. Okay. Chalo. Now we go for the next question. The correct statement about ozone is, first of all, ozone. If you see ozone, O3 has a resonating structure. When you draw a Lewis structure for ozone, you come to know it is a resonating structure. And because of this, the OO bond length is equal. Secondly, it has a bent structure. It has a bent structure. Thirdly, all electrons are paired. Since it is paired, therefore it is diamagnetic. It is diamagnetic in nature. And when you do the decomposition, that is O3, when heated, it turns into O2. Okay? It is exothermic. It is exothermic, liberating minus 142 kilojoules per mole energy. So now look at the option. O bond length are equal is a correct statement. Thermal decomposition of O3 is endothermic? No, it is exothermic. So this is a wrong statement. O3 is diamagnetic? Yes, it is correct. C is correct. O3 has a bent structure? Yes. So in this case, you have three options which are correct. That is A, C and D. Okay. So all the three statements are correct with respect to O3. Okay. Now we go for the next question. Which element is not considered as a chalcogen? Group 16 elements, oxygen family, is called chalcogens. Reason? They produce large number of compound, odes are produced. Now, all this option given to you belongs to group 16 only. But if you see very carefully, polonium is radioactive. So, since polonium is radioactive, it forms very less number of compound. So, it is not known as chalcogen. So, the option in this case is D. D is the perfect answer for this. Okay. Let's go for the next question. Which of the following statement regarding sulfur is incorrect? Okay. So, let's see the solution part of it. Let's take option 1. It says sulfur dioxide molecule is paramagnetic. It's a correct statement. Reason? It contains unpaired electrons. So all electrons are not paired. So option A is correct. SO2 molecule is paramagnetic. Second, the vapors at 200 consist mostly of S8 ring. This statement is also correct. Reason? We have at a lower temperature, we have a crown shaped structure of sulfur, S8 ring. So this option is also correct. Option 3, so you have a crown shaped structure at 600. Option 3, at a high temperature, it occurs as H2 molecules is a perfect statement. This statement is also correct. What about D option? The fourth one. The oxidation state of sulfur is never less than +4. Oh, this is a wrong statement. Reason? We come across so many compounds like hydrogen sulfide, in which the oxidation state of sulfur will be -2. In case of S8, the oxidation state is 0. In SO2, the oxidation state is +4. In case of SO4, 2-, the oxidation state of sulfur is +6. So the option D, which says that oxidation state of sulfur is never less than +4, is a wrong statement. So your answer for this question is D. D is the correct option. Okay. Now we go for the next question. Which of the following is not oxidized by O3? Ozone. So if you see the options very carefully, in the option 1, it is potassium iodide. I-1 is oxidized by O3 to I2. It gets oxidized. So Ki will be oxidized. In case of second option, Fe, ferrous, will get oxidized to ferric Fe3 plus by O3. In case of third option, Mn already has oxidation state +7. It cannot be oxidized. Cannot be oxidized. Reason, it is already in its highest oxidation state, +7. Whereas in the fourth option, Mn is +6, which can be oxidized to +7. So the answer for this question will be C is the correct option. So KMnO4 cannot be oxidized by O3. Okay student, have a look at this question now. It says 25 ml of a household bleach solution was mixed with 30 ml of 0.5 molar potassium iodide and 10 ml of 4 normal acetic acid. In the titration of the liberated iodine, 48 ml of 0.25 normal sodium thiosulfate Na2H2O3 was used to reach the end point. The molarity of the household bleach is. First of all, what is bleaching powder? Is nothing else but CaCl, OCl. That is calcium oxychloride. Now, how will you solve this question? For this, milli equivalent of Na2H2O3 should be equal to milli equivalent of OCl minus. So, how do you take out milli equivalent? It is 0.25 multiplied by 48, which will be equal to milli equivalent of OCl minus. So when you multiply it, you get 12. 12 is equal to the milli equivalent of OCl minus. Now, the n factor of OCl minus will be 2. Reason, Cl plus 1 will get converted to Cl minus 1 by losing 2 electron. So n factor will be 2. Now, millimole of Na2H2O3 is equal to the millimole of OCl minus. Now how do you take out the millimole? It is 12 divided by 2. That is the millimole of OCl minus. Now you got the millimole. That is 6. That is nothing else but equal to 6. This will be 6 will be equal to the millimole of OCl minus. So you got the millimoles. Now you wanted molarity. So how do you take out molarity? Molarity will be equal to millimoles, that is 6, divided by the volume 25 ml. So your answer for this will be 6 divided by 25. 6 divided by 25 is 0.24. So 0.24 is your answer for molarity. So your option C is the correct answer for this question. Yes, student, have a look at this question now. It says, which one of the following reaction of xenon compound is not feasible? Now, if you see these options very carefully, you know, xenon hexafluoride has a very high tendency, to undergo hydrolysis. So if you see very carefully, option A, the reverse reaction is more dominant. So in that case, xenon hexafluoride can easily undergo hydrolysis. So the reverse reaction is more spontaneous. So the one which is not feasible is the A option itself. Okay. Student, have a look at this question. It says, in clathrates of xenon with water, the nature of bonding between xenon and water is, we know that water is polar in nature, whereas xenon is non-polar in nature. It is non-polar in nature. Therefore, the clathrates will have dipole-induced dipole interaction between water and xenon. So the option for you is, which is the correct one, is A. A option is correct. Okay, with that we come to the end of this topic of P block involving group 15, 16, 17 questions which we have tackled it. Okay, so in the next lecture of ours we'll be starting with a new topic. Till then, remain safe, be happy and work hard. See you all in the next lecture.